Good afternoon, everybody. You're very welcome to the final day of CitA Tech Live 2020. My name is Alan Hoare. I'm based in TU Dublin in our School of Surveying and Construction Management. I'm also one of the co-founders of the Construction IT Alliance. This year our event is it's focusing on changing the way we work. This week we'll hear from 20 experts, voices from across the globe, who are already disrupting and introducing innovative approaches to how we work in construction. I thought I might take a few minutes just to recap on the learnings from the last 4 days and maybe pick out a few headlight areas for you. One of our delegates, Daniel Gorman, mentioned in the chat facility that really these speakers have been laying down benchmarks for AEC businesses. Even before COVID-19, we were experiencing change, transformational change of digitization, decarbonization, industrialization. But COVID-19 has accelerated these transformational forces. The big message this week is that we have to adapt, we have to change, and we have to embrace a new but yet uncertain future. Cultural change needs to happen in how we educate our people, how we organize our contracts and our supply chains. There's an increasing focus from project to data-driven management, and we must embrace new technologies and new ways of working. It was talked about incremental review of benefits and value as we go through the design, construction, and operational processes. So the big focus this week has been on collaboration and integration, driven by the need to leverage particular off-site methodologies supported by Lean and BIM and international standards of information management. So I suppose the big question today is, will COVID-19 actually accelerate off-site techniques? I suppose that's the challenge for our speakers this afternoon. So Shannon, you might share with us the program for this afternoon. Thank you, Shannon. So the focus of this afternoon is to look at the new norm of product-based modularization in construction. Our speakers are Raghi Iyengar, CEO and founder of Manufacton; Dr. Forrest Flager, Director of Software and Design Automation at Katerra; Anna Bergsten, Digitization Manager, Lindbäcks, Sweden; Roger Krulak, CEO and founder of Full Stack Modular; and David Purdon of Ditech. You're all very welcome this afternoon.
Hello, everyone. As I was saying, I'm Raghi Iyengar, founder and CEO of Manufacton. I think he's given a really nice background on me. I just wanted to say that I'm super excited to see where the construction industry is now moving towards this whole industrialization of construction, something that's been my focus for my entire career for the 30 plus years. In trying to make construction more and more like manufacturing. So today, what I wanted to talk about is this whole idea around the value chain revolution we are seeing as the industry embraces industrialized construction. So everyone has seen the usual aspects of the whole value chain. And we are seeing significant amount of disruption and opportunities that are emerging across all of the different stakeholders, people in the value chain. Really look at this whole idea of the construction, in industrialization construction. We are talking about modularization. We are talking about offsite. And what we're seeing is this whole idea of construction moving from the field to the factory. And this is, over the last 6 months, it's even more acute in terms of the response to COVID and everybody talking about the new normal, where they're all saying, hey, we need to take people off the job site into the factory so that we can kind of reduce the people in the field and so forth. And a lot of good work has happened over the decades. If you look at the kind of design build perspective, the PPP, the partnerships, a lot of work happening over the decades in terms of total quality management and the whole Lean Six Sigma, and with lean construction coming in and talking about pull planning and reducing the waste along the whole life cycle. And then I think I'm not sure if Phil Bergsten is in our in the webinar today, but he spoke yesterday or day before, and he's been instrumental in helping drive a lot of things around IPD and BIM. So a lot of good work that has happened. I see those as all being building blocks towards trying to get construction to be more efficient, to become more and more like, and now the result of all of that is industrialized construction is now going to be able to take advantage of all the work that's happened and now accelerate this transition of construction moving from the field to the factory. So that, now having said that, the reason why we feel as Manufacton have an interesting vantage point is because, I started the company 6 years ago, and what Manufacton is the offsite construction platform. It's a software as a service, as I said, where we've got single trade subcontractors using our prefab execution system. You got the modular builders, the multi-trade using our modular execution system, RDS, and the general contractors, construction managers, the owners using the construction execution system, Constructius. But the goal there around all of that is to manage your materials, manage your inventory, do your offsite production, coordinate your supply chain coming in, and then coordinate your on-site production in terms of completing the installation process and so forth. So since we are involved with all of these different players across the whole life cycle, we think it's been an interesting to observe what's happening in the industry. So I'm not going to talk deeply more about our product. Instead, I'm going to talk about what we are seeing in this whole industry transformation that's going on around in this process of industrialization of construction. So I think the interesting thing now would be to start off by basically looking at what's happening at the job site itself. So now all the general contractors, everyone is starting to think about, can the job site actually start becoming more like an assembly factory? So instead of bringing raw materials to the job site, can we not bring building components and systems and modules and everything to the site, and the site becomes more like an assembly factory, putting it all together? And so that's kind of the first step towards saying, hey, the industrialization of construction is moving construction from the field to the factory. Alan mentioned SIFE, the Center for Integrated Facility Engineering at Stanford. Paul Teichels, who started that in 1988, he's been my mentor for 30 years. And many years ago, he had said, why are we talking about what can we take offsite in terms of prefab? Instead, should we not be, what do we absolutely have to do on site, and start with the default position of everything should be done offsite? So, he wanted to, and this was years ago. So it's happy to see now everybody is really talking about why do we need to do anything on site? Instead, do everything offsite, bring it in, and run the site as an efficient assembly factory. So for example, this is one of our customers, Consigli in Boston, a very innovative general contractor. And here they had a project in Cambridge, Massachusetts, 50 Rogers, a very tight site, not enough space for for even materials to be stored on the site and so forth. And what they did was they said, okay, what can we take things offsite? So they coordinated the 3D model. And by the way, we work obviously with Revit, Navisworks, BIM 360, the Forge Viewer. So we have a really good integration with the whole Autodesk platform. So they completely coordinated all of the design with Sky Structures, which was in Canada, providing the steel frame for the building, Infinity Structures, creating the panels, the wall floor panels in Pennsylvania, SurePods, which was the bathroom modular builder in Florida, delivering bathrooms over to this project in Cambridge. And they actually coordinated in all of them so that everyone had complete visibility and control into the production progress and the delivery status in real time, around what's happening, not only with just consigibly with each of the players, but all of the players were coordinated with each other so that the job site could efficiently run like an assembly factory. So that's I think the kind of one area that we are starting to see all of the construction companies, the owners are getting involved in it, and owners are working with the contractors and the architects to say, hey, how can we try to do things more offsite, bring everything in? And this obviously is across the board more of a supply chain kind of a workflow where how do you get the entire supply chain to be able to do things offsite? And you need to know who is building what, where, when, how far along are they, when is everything going to show up so there are no surprises. So that visibility and control into the process is what these companies are all looking at. So that's step one. The other thing is, there's been a lot of conversation around the whole idea of taking building as a project and start doing building as a product, and this whole idea of productization. And the way we see this is, this product could be literally a mechanical assembly from a mechanical subcontractor, or an electrical kit or an electrical assembly from a single trade electrical subcontractor, to panels, to volumetric bathrooms, to volumetric apartments, whatever you're putting together as a product. The things that as part of the productization process that all of the companies are looking at is, what's our catalog, the kit of parts, in terms of what are the materials we need, what are the building components that we would want to bring in and to configure this product, and what are our preferred vendors, how do we want to source it from our vendors and so forth. And then leveraging once we know what that product is, how are we going to build it in terms of, what's the production recipes we need, what's our quality procedures, because you want to always have an approach around lean and total quality management and quality at the source. So making sure you have quality procedures for inline and during your production process, and then quality procedures for final assembly in the factory, even before it goes to the site and then finally at the site itself. So understanding so this whole idea of the kit of parts connected to the production recipe, connected to quality procedures, all that then coming together in the context of a project, which then goes through the execution process. So now the interesting thing is, if you look at productization, there are different players looking at it differently, and based on where they are in the value chain and where they're trying to aspire to be in the value chain. So the interesting thing here is, from a general contractor's perspective, what we are starting to see is many of them are either building modular factories or they're buying modular factories. And what they're trying to do is take their self-performed work offsite. So for example, a pretty innovative large general contractor in the US, DPR, they built out a factory in Phoenix to do wall panels called the Digital Building Components. That is their own factory. And then they purchased Sure Parts, which is a bathroom modular builder in Florida. And so now they're producing their own bathrooms and their own wall panels and so forth. And at the same time, they're working out their prefab strategy in terms of what do they want as far as their productization of other capabilities, where they might work with other modular builders, other panelizers, other trade contractors, in order to try to get everything done offsite before they come to the site. So that's a good example of how you've got a blended strategy of working with other companies and building your own factories, or in their case, buying one and building one. And then you've got a company like Skender in Chicago, which actually verticalized the whole process, where they brought in the design, an architectural firm, they brought in, and then they said, okay, we're gonna do the design, manufacturing, and construction verticalized for the residential, multifamily residential in Chicago. And they were using structural steel for it. And basically what they've landed up doing is, literally driving from their factory to be able to do volumetric apartments that they could then send over to the site for completing the installation. So you have Skender as a verticalized DMC company, Factory OS in California, where they have actually, Canon constructors, Larry Pace, merged with developer Rick Holiday, David Baker Architects, came together, and they actually, all three of them created a new company called Factory OS for wood residential multifamily in the Bay Area. And then you had Swinnerton, a large general contractor, they built a factory in Portland, Oregon to do mass timber modular. And then in Ireland, yeah, we've got Vision Built, which is a cold formed steel panelizing manufacturing company that has been acquired by CISC in order to do it. So, and I'm just showing you a few examples of how general contractors are getting into the game and saying, hey, we don't want to only manage the process, but we want to do more, and we want to get involved and try to drive as much offsite and do all of our self-perform work offsite as well. So that's one aspect of how general contractors are getting into this, into the game. And then you have your trade contractors, the electrical, the mechanical, the concrete, the facade, different types of trade contractors. And what they are doing is they're also integrating vertically. So they're going through and saying design to fabrication and installation, and they're getting involved, design assist, IPDs, and trying to get early in the process to partner with the owner, architect, and the general contractor, so they can help provide influence and get a better outcome for the entire team. And in addition to integrating vertically, they all have experience already with doing prefab. They've done a lot of prefab over the years, got the benefits of it, they're recognizing the margins and all of that. And now in the context of this whole drive towards more and more offsite, they're all busy increasing their capacity. And as they're increasing their capacity, they're also saying, hey, we have our expertise for our trades, we have increasing our capacity, we know how to do these things. And now what they are doing is bringing in other trades into their factories in order to then expand into a multi-trade. So not just this one example, but for example, T.G. Gallagher as a mechanical subcontractor saying, I can bring in electricians and carpenters and everyone into my factory here and start producing bathrooms. And we become a bathroom module manufacturer and not only a mechanical trade contractor. And then, so that's kind of the thing that's happening around the trade contractors. And then if you start looking at things in the context of the material suppliers. So now this has been another interesting thing in terms of the value chain, where obviously the big players have always been there, where they have said, hey, we can now partner with the owners and partner with the general contractors and say, we can not just provide you materials, but we can start providing you systems and building components and everything else. But now we are starting to see the mid-tier, even distributors and middle players as well, all coming into this, into the process, and by going up the value chain and saying, you know what, instead of you building production capacity and all that, we have production capacity. So why don't we can do multiple things. We can either send raw materials to your job site, which we have always been doing, and we can continue to send raw materials to your factories, which is perfectly fine if that's what you all want. But in addition to that, or instead of that, if you want us to actually create building components from our raw materials and provide systems as an engineer to order for you, we can do that and send it over to your modular factory or your prefab factory, so that you can have to do less in terms of your capacity expansion and still get all the benefits for it. So now all the modular builders and the trade contractors and all of them in their factories, as part of their vendor sourcing, they're not only looking at these material suppliers to deliver material to their factories, but they're looking at them as building component manufacturers who can take engineering to order and start bringing those kinds of things in here. So those are the kinds of things that we are seeing across the board between the general contractors and the single trade contractors and the material suppliers, all of them looking at this in the context of, what can we do more and go up the value chain in order to be able to help leverage their capabilities, their capacity, and obviously make more, get a bigger share of the scope of the project, and through that make more money and so forth. So that's the way we've been seeing this. So from a Manufacton perspective, and when we talk about industrialized construction with Manufacton, we have this opportunity, like I said earlier on, in terms of our vantage point, where we're working with all these different types of companies with different starting points and going down their journey to different destinations that they all want to go in this value chain, where we help with them through the design process where they can start creating their kit of parts and their catalog, process templates, drive the BIM to production and installation with the bill of materials, tie into the construction schedule for, understand what the pull plan is in order to create their design backlog, as well as an agile production plan from their manufacturing backlog, tie their materials and the building components, as I talked about, where they can say, what materials do we need for what production, and how do we build our components, sub-assemblies, assemblies, modules, and manage all of that, and drive all that through the whole QA, QC, quality control, both inline production, through every step of the way, as well as final production, assembly, and so forth. So that way, when things go over to the construction site as an assembly factory, you've already done quality at the source. So when things come into the site, you've got the ability to now drive all of your, you've got the logistics, you've got your site readiness, coordinated with your supply chain readiness to make sure that there are no surprises in terms of what your installation sequence is and what you want to do in terms of final requests. And the really good thing, especially among trade contractors, what they have started recognizing is this whole concept of field requests. So if something has not been figured out up front, the people on the foreman on the site, the superintendents, prefer not to build from first principle for something that was not caught during the planning, and not build that at the site, but call it as a field request into their factory so that they can create those components, sub-assemblies, and so forth, and send them over. So that culture of continuous improvement where you can start driving from construction into the manufacturing and into design, and then the manufacturing folks feeding into the design. That's where we are starting to see some really good work that's been going on over the last few years. And we have been sensing over the last 6 months during this COVID time period that everybody is now, this whole thing is accelerating, where everyone's really all putting all of their energy into this. And they're all been telling us, at least, that in the new normal coming out of COVID, they all see industrialization of construction is the way to go. And nobody is even now questioning why should we do it, and and so forth. They're literally figuring out how best to do it from their vantage points. So that's kind of, I wanted to share that what we have been seeing in terms of this acceleration towards modularization and towards offsite.
Thank you. Great overview, and a nice way to end the message that industrialization is the way to go. Thank you, Raghi. That was an excellent presentation. We have a few comments on the chat. I think, Ralph, you might have a question there. I think I prompted a comment by saying that, how early in the process should we be bringing modularization into the design? I know Ralph might want to elaborate on that.
Yeah, well, it's one of the challenges you see that most projects progress quite far into planning, detailed design, tender, before the decision is sort of considered to whether to go modular or offsite. And then often the effort to try and reverse engineer a project into a modular offsite solution is too expensive or too disruptive, and that becomes a stumbling block. Of course, the procurement route that you choose would be impacted by making early decisions to engage with providers, because I suppose a lot of particularly public clients would feel they still need to go through a traditional tender process under public procurement. So I just wanted, the question really was, how do you integrate the suppliers into the early stage design?
So at least from what we have been seeing is each of the kind of the modular, especially if you look at it from a modular builder's perspective, the modular builders have been working with developers, and they have been saying, hey, we want to go up and try to do this from the get-go. And then you got they've got their productization that they have done in terms of how their different scenarios that they would like to productize with their modules, and they have worked with their preferred group of suppliers, vendors who can literally cater to their product in terms of their components from an engineer to order and that whole thing, and they've established those kinds of partnerships. But those would be, like you said, for the ones where right from the beginning, they have been able to, to do this, but, and be able to drive it from the start. But then we've also been seeing the projects where they're not thinking about modular from the beginning, and when the design is far along and it's actually as more of a means and methods scenario, right there is where the general contractors coordinating it, of course, with the architect and the owner, but then working with their team of subcontractors and saying, okay, what can we do to take things offsite and prefab portions of it, so it may not be full modular as a building, but a lot of it can be then taken offsite. And there you got all of their suppliers coordinating with those trade contractors. So it's not a one process that that's working. It's almost like it's all been highly opportunistic and where they've been able to do it. Except now it's becoming more and more mainstream, where they're almost like every general contractor sitting down with the subcontractors says, okay, what's your prefab strategy and prefab capacity? And then the owners and the architects sitting down with the general contractors and saying, how far along are you and what's your experience been with modular and offsite? So it's kind of now starting to become what used to be a decade ago around, hey, what's your BIM capability and VDC capability, is now becoming more of what's your industrialized construction capability around modular offsite, both at the general contractors and then each of the trade contractors, along. Yeah.
I think Martin Searson had a comment about the current barriers to implementing modularization, drivers, and whether there needs to perhaps to be an education of clients, or is it down to how we organize our contracts and our procurement, that the client traditionally would go to an architect first, they would traditionally design, go to planning, then the design would develop, the quantity surveyor gets involved, and almost modularization is thought of too late, or if it's taught, and do you have Martin, do you want to elaborate on that question?
No, that's correct, Alan. Yeah, no, just how do we implement this? How do we start adopting more of this modularization and help speed up the productivity out in projects? That's the key.
Yeah, and I know you also mentioned, Martin, about the need for standardization. Are there standards out there for, we talk about data standards. Are there standards out there for modularization?
There's industry standards and building standards, but what we find is some of the modules that arrive, especially on the M&E side of it, aren't in compliance, or they arrive to site and then we have to do variations or rework to bring them up to compliance, because they don't always fit, or they haven't been thought about fully in the original design or specifications of the project, because they've been built off site or remotely, so it's trying to integrate that together. That's really the question.
Ross Griffin has a comment about cost management. Ross,
how's it going, Alan? How guys?
Hi.
Yeah, just kind of to support Ralph's question there. The business case is vitally important. So these discussions of modularization, offsite construction need to happen very early, because there's a cost impact and a risk for clients. But on top of the modularization, what about the circular economy impact of modularization? Do we get the flexibility in our construction to allow us to reuse our buildings in the future for different purposes if we all focus towards modularization? And I'm not talking about offsite, it's purely about the modular aspect.
So a question for Raghi? Raghi, did you pick up that question? Did you?
No, I wasn't.
I go again, Raghi, quickly for you. Just to on the circular economy, which is the most important part of this, is modularization in itself reduces flexibility within the building in terms of altering the building use in the future. And with circular economy, we have a big focus on building reuse after its life cycle, with refurbishment, for example, and whatnot. So does modularization affect that circular aspect for future reference or for future buildings?
We've been hearing that a lot, right? Especially I think we're still in early days for that, but people are talking about, dealing with, not only design for, manufacturing and then construction, but also quote unquote disassembly or end of life after that, and what can it be actually used in other aspects, in reuse subsequently and so forth. So that whole sustainable aspect of it is coming together. But I think the flexibility part of it, I think, is going to become really interesting, because today people think by doing modular, you're actually constraining yourselves and you're being less flexible. But then there is the history around the automotive where they've been incredibly creative, even though things have been done, quote unquote, in a modular approach for decades. And then we have in this group as well, where he was in the early days, everybody was saying, oh, BIM means an architect is now no longer going to be able to be creative. And Phil had to educate everyone saying, no, it actually provides you more flexibility, more capability. You can actually think even deeper, more, and all of that. So even modular, the fact that now you can move things over into a factory and you're not constrained by site material requirement and site skills required to do things, you can probably, with modular, once we get through this initial phase, we might be able to get even more creative in terms of advanced materials, advanced methods, advanced options. So you might actually have greater options in modular than what we have today, which I think is still the starting point.
Yeah, we have other questions coming in, but I might take those a little later. People mentioning things like we must start with the end in mind. If we think early about modularization, then the benefits will flow later in the project, and you end up with a better green footprint of the building. So thank you, Raghi. That was really excellent. I think you set the scene really nicely.
Absolutely. Thank you, Alan. Yeah, so what I'd like to speak to today, my background is more on the technology side. So specifically this question of how do we address localization in an industrialized construction context, the idea of sort of mass production versus customization, and specifically how Katerra views this, and how we're developing technology to kind of support our philosophy. So first, I just like to start by giving a little bit of background on the company so you better understand where we're coming from. So for those not familiar with the company, it was founded in 2015 and has grown quite rapidly over the past 5 years. It's currently at just over 8,000, and it's quite a variety of different backgrounds that have joined. The founders of the business came from advanced manufacturing, and so we have an interesting mix of those coming from a technology background, manufacturing, and AEC, which from my perspective has created a lot of great learning opportunities. Also is kind of challenging in that the sort of vocabulary and approaches are quite different in each of those industries, and I'll speak a little bit more to that later. So the offering of Katerra is that it's a vertically integrated business that does design, offsite manufacturing, assembly, as well as material supply for a couple of different building materials, including cross-laminated timber. In terms of the type of projects that Katerra is involved with, you see quite a number of different building types here. Katerra has grown through acquisition of general contractors in the United States, and so we have quite a variety of offerings from a construction perspective. In terms of sort of the productization of the building, where we're offering that sort of turnkey vertical integration approach, right now that's we have two different products. One is a multifamily product, and the second is a commercial office building. So although we're acting as the GC in all of these areas, the sort of industrialized construction approach is limited to those two building types. The type of manufacturing that Katerra is involved with is panelized construction in stud walls, wood and light gauge steel stud walls. You're seeing on the image to the left is our factory in Tracy, California, in the Central Valley, that does wood and light gauge steel stud walls, cabinets, and windows. We have a mass timber facility, CLT factory in Spokane, Washington, that does panelized CLT. And we have a precast concrete facility in Bangalore, India, that does volumetric precast concrete to serve the India and Saudi markets. So that's a little background on the business. I kind of use this slide to preface the sort of technology approach. So this is actually the first targeting system that was developed for fighter planes. This is the Spitfire plane, which was a British fighter plane in World War II. It was one of the first times that they mounted machine guns on airplanes, and they realized early on that pilots weren't very good at hitting the target because the speed of the bullet relative to the speed of the plane. And so they developed this sort of analog targeting system in which the pilot would literally have to turn a knob to adjust the size of the sort of targeting circle, and that would give an estimate of range, and they would want to make that range like relative to the wingspan of the plane roughly, and then they would press a button, one of these 6 buttons, to indicate the direction, and then they had a mechanical system that would like lead the guns accordingly to allow that to hit the target. And I think this is an analogy on the technology side. I mean, I think a lot of technologists approach it from a technology first, and there is innovation comes that way. But I think you have to understand where you believe the industry is going, and then technology is really a means to sort of help you achieve those ends. So for the purpose of discussion, I'm going to kind of talk about 3 things that we think are inevitable that will change the industry, and then how the technology we're developing is going to help us position us to take advantage of those opportunities. The first is industrialized construction. In this audience, I'll go pretty quickly through this section as I think it's well understood. But this, for example, is the information on how the price of a home in the United States has changed over the past 50 years or so. This is normalized for the cost of land. So you see, the cost is, gone up in real dollars quite a bit over this period. And the mix of, the components of this cost, labor and materials, has remained relatively static over this period, with labor being, the majority by a small amount. I mean, this of course varies by the building type, but these numbers are sort of roughly accurate. And then if you compare that to sort of other manufactured products, you see in many cases the opposite trend, in which the real cost of these products has remained relatively flat or even decreased in some cases. And those, it's a slightly different time window, but a lot of the drivers behind this have been through advanced manufacturing, being able to reduce the labor. In many cases, a lot of these products have less than 15% of the overall cost is labor, and also there's been some material innovation as well. So we see an opportunity in essentially applying these principles through advanced manufacturing to buildings, as many on the call do as well. So the second piece is that this industrialized construction approach will involve mass customization. And the reason why I say that is due to the kind of unique environmental factors that affect buildings that are different, I think, than other products in the marketplace. For example, this is a seismic map of the United States as some estimate of the structural forces that appear on buildings for the lateral system. And we have a multifamily product, a 24-unit garden apartment building And we developed some software automation that would enable us to essentially design the structure of this building automatically under different environmental conditions. So we did an analysis that looked at different soil types and seismic zones, and we estimated the cost of the structure in each of these different environments. And what we found was the cost of the structure had more than a 2x differential, depending on where it was located within the country. So when you start thinking about it, as Raghi was saying, like the level of standardization of the product or the kit of parts becomes very important. We really believe this is the case because if you were to adopt a standard approach to the design of the structure, you would be paying that premium, right, by essentially over-designing for sort of the less demanding environmental conditions by 2x. And even if you started to develop different tiers, for example, a different structural design for each seismic tier, when you're talking about those kind of cost differentials, even if you did have, say, 4 different tiers of the structure, you would still be paying a premium of, let's say, roughly a little over 10% on average, right, by bucketing the design so coarsely. So things to think about that inform kind of our approach to the kit of parts and productization is, how do you design to be material efficient and cost efficient to all of these different localities? On the mechanical side, these are the different climate zones, heating and cooling needs. We found the capital cost to be less significant in this case, roughly 30% or so. But if you start looking at life cycle performance and how efficiently these systems operate from an energy efficiency perspective, then again, customization of the system becomes more important in terms of designing for the life cycle operational efficiency of the buildings. And finally, from a market perspective, this is an indicative map of construction labor rates. These aren't accurate. I just wanted to share a representative example. The point of this being that the site labor rates for construction vary more than 2x across the country. In fact, as one might expect, the Bay Area, where I'm located, has some of the highest construction labor rates in the country. And this is kind of interesting when you're thinking about an offsite approach. The economics of how much work you do in the factory, what we call the level of completion, from a cost perspective, the optimum there varies depending on how expensive that work is to do on site. So if you're in the southeastern part of the United States where construction labor is relatively cheap, you might want to do less work in the factory compared to other markets like the Bay Area. And how do you design a system that is able to essentially have different levels of completion depending on the market? So in order to achieve that, Katerra has approached it and how can we leverage technology to essentially assist our designers in developing these sort of mass customized solutions. So to talk a little bit about that, I think this is the 24-unit garden apartment project that I mentioned previously. Of course, there's an element of modularity to the design. Katerra approaches it as many multifamily designers do, from the unit first. So we have several standard units that can be combined in different ways to chassis, which are essentially, there are 3 chassis to each 24-unit apartment building. And then from that base standard set of units of, 12 or so different units, we can get quite a variety of different building types that all fit into this modular scheme. And that enables us to meet, different market performance. So that's one effort of modularization. One of the main challenges that we faced is developing that fabrication level of detail model and doing that in a cost efficient and timely way. So early on in the business, we would have the architects and engineers designing a permit level drawing. and model in Revit, but that wasn't really designed with an eye towards fabrication. And so our sort of component design fabrication engineers were rebuilding the model from scratch to create a fabrication model that has every stud and every piece of hardware located. It's taking quite a lot of time and cost. So using software, we kind of changed the approach, and we had specific BIM standards in which the architects and engineers had to use a kit of volumetrically accurate components and attach metadata that would specify the framing types. That would also drive the drawing production, but it would also be used by the software to automatically lay out the framing and place hardware, so that wouldn't be a manual step. So we applied this kind of systematically over time to reduce effort in the sort of component design phase. So I won't go into detail of all of the different steps that the designers would do to create a fabrication model, but we looked at what of those steps could be automated. And over time, you know, today we're at roughly 30% of the effort that we were in late 2018. And what's kind of interesting about that is it really changes the skill demand of what we need on the design side. So before automation, we had kind of this mix of, you know, roughly even percentages of novice being like less than, you know, 2 years in the trade, and journeyman, and then experts meaning, you know, 10 years plus. And what we found, you know, after the automation is that we needed less of sort of the entry level folks, as you might imagine, because those tasks were often helped with the software, and we needed relatively more. I mean, the size of the pie isn't the same in each case, but the demand on experts to really handle the unique cases or quality control the output. And so it's interesting, like, what does that mean in terms of young designers entering the industry? And we're already seeing it is a lot of the designers have some background in technology and software development, and so they become tool builders and contribute to the business that way. So we've paired young designers that are able to develop scripts and automation with our more experienced designers, so they're working together to build tools that will enable the business to be more efficient. The final point that I wanted to make is, and I think Raghi touched on this, is this feedback loop of, you know, once we really understand the production system and we have an automated design, we're able to, you know, rapidly iterate and do some very interesting things from a product development perspective. And I think that's really exciting for the industry. I'll touch on a couple examples briefly of that. So this is a very simple one. We're doing the, you know, so a stud wall, for example, 2 different types of construction, but structurally equivalent in terms of their performance. So of course we would like the engineers to specify the cheaper one for Katerra to build. So how do they understand which of these walls will be more cost efficient? Early on in the business, I don't think we understood this very well. But you know, in this case, we have quite a different range. If we were building this wall in the field, these would be equivalent, or the type A might actually be cheaper. But given the specific factory equipment that we have, things like the automated equipment is able to handle single studs more efficiently and a certain orientation of sheathing and nailing, it was actually quite a bit cheaper to do option B. So we developed a system which is really about understanding the production system. So, you know, this is a map of our factory layout. We collect data of every panel that passes through the factory in terms of how long it spends at each station and what material is installed. And once you have, you know, several thousand panels of data, you can start to do predictive modeling by analyzing that data, so that at the point today, we can actually feed it an arbitrary panel design, and, you know, using machine learning, it's able to predict fairly accurately, you know, what the cost will be, the total manufactured cost will be of that component. And what that enables us to do, and is kind of interesting from a design perspective, is we can surface that information to the designers so that instead of them specifying the construction of the wall, for example, they just, they're defining the design space in terms of what different materials they want to use, what different spacings and sheathing type, and what performance they need out of the assembly. And then they submit that, and then the system is recommending an ordered list of constructions by cost that best meet that criteria. So the engineer is, recommending performance, and the technology is helping them understand cost. And what's important about that is the factory is pretty dynamic. That they're constantly changing the layout or the equipment, and at least that's the case in my experience. And so this system is constantly learning and updating itself based on what is cheapest for the factory today. And so that enables the designers to have current access to that information. We've gone back and sort of retrospectively analyzed past buildings, and that's enabled us, to look at, millions of options instead of traditionally, just a few that would be done manually and achieve some margin. So we're not talking about huge margins here. I mean, just an extra 10%. But if you imagine this, I think many of the building systems can be optimized in this way. And if you're able to do this systematically, you can achieve, meaningful differences in cost just by understanding your production system and surfacing that information up to the designer. And the final piece that I wanted to talk about is really about the bill of materials and developing material forecasting. So one of the challenges that Katerra had was, there's an advantage if you're able to understand your material demands early. You can, buy more from primary suppliers at a discount. And we weren't very good at doing that. So we've gotten better over time by applying some technology. So right now we have all of our Revit models in the cloud. We're able to analyze those at various levels of design and fill in any gaps. So if the structural hasn't been designed yet, we're able to look at historical data to fill in what materials are likely to be demanded, and then surface that at a portfolio level to our materials group so that they have, say, a 12-month forecast of what the material demand will be. And that's enabled them to negotiate this better pricing with suppliers, since they don't have to buy their material from distributors or reps on short notice at a markup. With that, just wanted to touch on a couple of the technologies that we're developing to try to enable that tighter integration between design and production. So I'll turn it over to you, Alan, if there are any.
Thanks very much, Fraser. That was excellent. So it's obvious then for companies like Katerra that you're constantly making improvements, learning how to make to remove the rework and to become a leaner manufacturing company, I suppose. So my question is, to what extent do you look at lean construction and, the Toyota production principles and all that? Is that something that?
Yeah, I think it's. I think we do. In the same way, I think one of the learnings has been that needs to extend beyond just the factory, right? To the site as well. You can't just optimize for the productivity of the factory. And one example of that is like, panel sizes and how panels are routed through the factory. That has to relate to the erection sequence, right? There may be a most efficient way to fabricate those. Of course, they have to be pulled off the truck in a certain order to be set on site. And so you end up with these, it really needs to be holistic optimum in which you're considering, on-site assembly, logistics, and fabrication. And so that's, from a technology perspective, I think that is something that you have to be able to look at that overall. And I think.
So are you developers as well, or are you mainly suppliers of modular buildings?
So no, we're not developing.
You're not
so
developers.
it's a turnkey supplier of Modular.
Okay. Okay, so thank you very much, Vega. That was excellent. Do we have any questions for Fraser? I mean, the machine learning aspect is really interesting. I know Phil, is Phil with us? Maybe he's not with us, is he? I don't know. Listen, thank you very much. Great presentation for us. Thanks. Do you currently use or plan to implement machine learning? Question from Thomas.
Yes. Yeah, we are currently using it. I think just one note, the actual technology piece is pretty basic. We're using just off-the-shelf machine learning algorithms. The real challenge has been the data perspective. You need a lot of high-quality data, in this case, historical data from panels going through the factory. It took us quite a while, I would say over a year, to kind of perfect the data collection aspect of it, which was far more difficult than actually developing the technology. So I think that's, for those thinking about that approach, like really start with the sort of data preparation and cleanliness. I found that that's always the sort of long pole in the development of these technologies is, how do you get the right data? And we're trying to do that based on some of our site work today. And that's even more challenging, right? Because you don't have the same controlled environment. But if you have that in mind, from the beginning, I think you can build systems that will collect more granular data on site.
You mentioned that you've got a footprint in different parts of the world. So I think Brian Kennedy has a comment there. Was aligning local and international building regulations a challenge? When you're working in a certain jurisdiction, how much do you have to align and adapt your product to those countries?
Quite a bit. In fact, we don't, none of the products, for example, we have a US set of products, which I've talked mostly about today. We have an entirely different product line that will serve India and Saudi. So they're quite a bit different. From a regulation perspective, as well as like what the demand is. Even within the US, there's different there's different regulations by state. There's like factory built housing programs that are different by state. So it's been a challenge for us actually just developing products that can be used across the 50 states in the US. And we're still in progress. Today we've only certified our products in a handful of states, five states today. So.
And we've good afternoon, Ian. We've a question from Ian Kyo there. Do Katerra have plans to open up an EU base?
No current plans. We did have a CLT sort of research facility in Graz, Austria, but that was our only EU presence. So no current plans to.
Okay. I'm sure there might be other questions for you at the end. So thank you very much, Fraser. It was an excellent presentation, and wish you every success, and hopefully we can stay connected.
So Lindbäcks, as you heard, we are one of the leading modular construction companies in Sweden. And we've been around for a little bit more than 95 years and still learning. I will talk a little bit about modular construction in Sweden in general and digitalization, what we have done at Lindbäcks. Touch a little bit on sustainability and how we have seen the effects of COVID-19 in Sweden. So modular construction in Sweden, 45% of all housing construction have some level of site construction or panel or modular. So it's quite a big industry in Sweden. We have different type of frames, but mainly high quality timber. We have a lot of wood in Sweden, so it's natural to be using that. Sustainability, time on construction site, and quality, being able to do most of the construction in in-house is driving forces that supports the modular construction. There is a range within the companies that are in the modular construction business, from family houses that are kind of delivering products to projects where we are working, from single family to multi-family, hotel, student and retirement homes, and so forth. And how the business is done, it's kind of different. If it's a one family home, it's more from the catalog part where you have the product, or we have companies that is quite far ahead in the digital part, where they can configure online their houses, mainly more simple houses like garages and so on.
Anna, you might just want to elevate your voice a little bit.
Yeah. Okay, I think we have the
no, that's fine. If you just kind of,
yeah,
that's fine.
Okay, thanks. Yeah, and the traditional tenders is one part that we sometimes get in touch with, but most of the time we try to collaborate from idea to finished products with the owners. We have seen also that the modular construction companies in the market has increased in the last 5 years. And we have new players coming in, both domestic and international. If we look a little bit at Lindbäcks, we started in 1924. In 1994, there was a change in regulations in Sweden, so that we were able to build higher houses in wood. So that was when we started going into the modular construction. In 2018, we started up a brand new factory that more than doubled our capacity. So that's where we are now. And this is the family that is running the company at the moment. Third and fourth generation, you see here. What we are building, it's 2 to 8 story family housing, condominiums, student homes, rental apartments, retirement homes, and some hotels as well. The production process is that 32 weeks before we start in the factory, the engineering starts. And then we are in the factory 2 to 4 weeks, depending on the size of the project. And then we transport the modules either by truck or by boat. And then we assemble 2 to 4 weeks on site, and we have a finalization period of 6 months roughly. And here is a short video that I'm going to play that shows our new factory.
Hi, I'm Henrik and this is our factory. We are an industrial building company using wood from the northern forest, creating apartment buildings in Europe's most modern production facility. In a weather-protected environment, the volumes are built, step by step, along our preparation station and our main production line. Our building system can fill many different needs. We build everything from student housing, rent-controlled apartments, to condominiums and retirement homes. We offer a full-service solution where we take responsibility for the entire process. This means security in terms of price, product and delivery times. Along the wall line, the exterior walls are put together. Here, we assemble windows, bolt, insulate, and paint. When the wall is ready, it proceeds to the main production line for assembling. In parallel, the partitions are built and roofed. Just as the exterior walls, they are fully finished when they are assembled. The main production flow begins with the construction of our floor structure. Then our composite bathroom is put in place and partitions are applied, as well as exterior walls and ceilings. The main production flow begins with the construction of our floor structure. Then our composite bathroom is put in place and partitions are applied, as well as exterior walls and ceilings. When all elements are put together, we install the kitchen and apply the floor surface layers and complete with plumbing. After that, we review the volume to ensure quality. In the last step, the module is sent to the automated warehouse. Here it's collected by an autonomous robot that loaded on the trucks. All that's left is delivering to the construction sites. Thanks to our industrial construction, we manage resources efficiently and build climate and cost efficient with high security. We build industrial because we believe in creating homes for more people. We build industrial because we believe in living for more. We build industrial because we believe in living for the many.
And these are a few of the projects that we have finished. So this is in our hometown, Piteå, where we built Tallen. This is here in the Stockholm area where I'm also located, where we have built condominiums, 203 apartments. And digitalization then, going into that part. Where are we now? We see that in the industry in Sweden, it's starting to mature, it's starting to happen in things. Some have reached further than others, but most are on a journey and we still have a long way to go. But there was a recent poll done by a company, and they were asking people working in the construction industry on site and with engineering and so on. And it shows that 83% of the workforce believe in digitalization. 97% think that they will use more digital solutions within the coming 3 years. So there is starting to become a kind of a pull effect that people are asking for digital solutions rather than being pushed on them. At Lindbäcks, we have been implementing quite a few digital tools to support our processes over the last years. It has been incremental and continuous improvements, around 80% of the effort, and some experiments where we work together with the universities to develop new things and test new things and learn. So some examples of what we have done. We are working with lean principles as well. So we have created a planning tool which contain quite a lot of information about what is needed in a project at Lindbäcks. So you have on the left-hand side, you have all the roles in a project, and then you have the weeks and what needs to be done for each role and each week. And then we can follow the progress with this tool. We have also a way of doing deviation reports, and this is to be able to learn with 2 factories and around 20 building sites spread all over Sweden. It's hard to get the feedback loop working. So we have this tool where every function can report if something that they have received is not fulfilling what was the plan in quality-wise, and directing it to the right function. And we follow up that. So it's a mechanism for continuous learning. And this also ends up in us doing these daily huddles. So 7 o'clock each morning, it starts out on the building sites and in the factory. And then it goes up the chain of command with questions on if everything is okay or if we have any issues that needs to be lifted. And at 9:15 each day, the management group has a meeting, 15 minutes, where they go through if there is anything that needs to be taken care of right away. The figures that you see here is the different areas that we follow up. So it's, since it's Swedish, it stands for safety, quality, delivery, economy, and employee, and how they are feeling and doing. We also follow up the planning that I showed you earlier. Do we have any late deliveries that needs to be taken care of? And also, do we have any deviations that hasn't been answered in the time that is set depending on the priority? And we see how much they have in each inbox of the deviations as well. We have also spent quite a lot of effort in the new factory. We have a project called 10S, which means that it shouldn't take more than 10 seconds for someone working on the assembly line to find the right drawing, the standard operation sheet, and bill of materials. We also have digital quality control that is made in the factory. We have the automated wall line, and we have the automatic warehouse that you saw in the movie as well. We do condominiums where we are the developer as well, and here we have had a way of communicating to the end customer so that they can follow the process from when they have bought their apartment and what is happening when it goes through the factory, when the assembly starts at the production site, some words from the architect, and so on. It's been quite, the customers have liked this, to be able to follow their own apartment. If we are looking ahead, what we are focusing on now, we have grown quite a lot in the last 5 years, more than double in number of people and operating earnings. So we have, we need to focus now on the end-to-end process. We have been good at doing stuff for every function, but now we need to take the next step to be able to have the information flow in a more effective way. We also need to look into the infrastructure to enable us to take part of all the new technology. Also going from looking at systems as separate parts and more thinking platforms. We see that there is a need for solution on the construction site. They could need a lot more support. And we want to develop our BI even more, so we become more of a factory-driven decision-making company than we have been. We also have always been talking a lot about sustainability, but with the requirements that comes from customers and from other areas, now we see that we need to be able to follow up components that we build in and be able to produce more information connected to sustainability. And also looking into what could be the digital delivery of our products. What is it, something that we build into the products like sensors and so on, or is it a BIM delivery that could be used for maintenance of the facilities and so on. We do a few innovation projects together with universities. So we have one that is nationwide, that is called the Connected Building Site, where we are involved. And here we are trying to develop a good way of doing these quality controls on the building sites, which we see on the left-hand side. Being able to take pictures that, first of all, plan what quality controls that are needed, take pictures of them, and then save the pictures in the right way so that they are easily found when needed and can be shared with others. And we also look into all the new technology solutions and how we can use them. When it comes to the Arrowhead tool, that's a European project, more focused on the Industry 4.0. There we have a collaboration between 3 companies in the north of Sweden, trying to get our engineers to be able to draw the bathroom pods, and without any other involvement, run the machines at the delivery, the supplier of the bathroom pods. When it comes to sustainability, we have been working with that, as I said, for quite some time, even maybe before it became a buzzword. But now we have, during last year, we have defined our sustainability strategy to be more crisp, and we have a sustainability report that we have been published. It all is developed from the UN Sustainable Development Goals, and we have selected to focus on 4 areas, which in turn kind of connects to 7 of these sustainability goals. We have named them engaged employees and sustainable work environment, our climate footprint and effective use of resources, responsible business and attractive real estates, and finally, sustainable urban development. And some figures that we have been working on is that, I don't know if you noticed, but when you saw the movie of the factory, we have solar panels on the roof. Mm-hmm. Those produces 688,000 kilowatt hours, which means that we are self-sufficient. By using environmental fuels in all our trucks, we have saved 375,000 kilos of greenhouse gases. By working with wood, the sound is less noisy during construction, and it's a shorter time on the site. And we have now 19% women in our organization, which is still far from 50-50, wow, but much higher than the industry average, I would say. And then for the last kind of touch point, COVID-19. Talked to Alan before. I don't know if it's right to say that we have had liberal restrictions in Sweden, but at least we have had others than most of the world around us. It has been a mantra: wash your hands, keep physical distance, work from home if you can do your job from home, and stay home if you're the least symptom. That has been kind of the restrictions. So for now, we haven't seen that many effects on us as a company. We have had minor shortage of a few materials, but nothing stopping productions. But I'm more concerned about the long-term effects of the economy and the will to invest. So that's kind of my what I see could be the effect for us, at least. So, thank you.
So Anna, thank you. You did a great job, and I think you've brought things nicely together for us, because Lindbäcks are a sustainably focused industrial company. Yeah?
Yeah.
And you're bringing in inclusiveness, diversity, you're measuring all the data of a modern construction business. And that ties us right back to day one, speaker one, who spoke about all of these things, that, you know, that footprint of sustainability needs to be there. So as usual with my chairmanship, we're running a little bit behind schedule, but Ali did a great job. Thank you. It's always insightful to get, you know, a lens into what other countries are doing and what other companies are doing. And so when I found you online and I found your company, I just thought it'd be an interesting story, and you certainly did a great job, and wish you all the success going forward with the company. Do we have any questions there for Anna before we move on to our next speaker? I think was it Simon had a comment? Is Simon with us?
Yeah, can you hear me, Alan?
Yes, Simon.
Yeah, no, I was just wondering, how are you framing your multi-story wooden modules? Are you building off a steel frame, or are they structurally strong enough to support themselves?
They're structurally strong enough with a wood frame.
Excellent. That's it. That's my frame. It looks fantastic.
Yeah, no, it's what's fascinating is the percentage of residential projects that are modularized in your country. 45%. That's extraordinary. We could learn an awful lot here in Ireland because we have a significant housing shortage here, and obviously offsite is something that's happening. So listen, we're going to thank you, Anna, and
I appreciate it, Alan. And yes, my name is Roger Krulak, founder and president of Full Stack Modular, and we are a fully volumetric design, manufacture, construct solution focused on sustainable construction in the dense urban environment. And I thought I would spend some time today talking about the process necessary in order to create effective buildings, both high and mid-rise in the cities and others, and the parametric design process that we utilize in order to achieve that. So I'm going to hopefully share my screen.
Yep, you can share your screen there now. Yeah, you're good to go. Yeah.
Thank you much. So, so the title of my talk and the conversation that I want to have today is about parametric design, and I call it the first step to effective DMC, which is not only an old rap band, but also stands for Design, Manufacture, Construct, better buildings built faster and cost effectively. And we have heard over and over again throughout the last days about how important it is to focus on a potential solution and change the process and paradigm by which we create the built environment. And our focus is specifically on multifamily. Behind here, you see what is still the tallest modular building in North America and no longer in the world, which is actually exciting to me. We know the reasons that we have been focusing on off-site built construction. The shifts are adding, but we have also in the United States a massive housing shortage. Skilled labor is both dissipating and being eliminated in many cases. And of course, we know our design bid build process in the world.
Sorry, Simon, are we seeing your screen there? Your actual presentation?
Are you seeing it? No.
No, we're just seeing the CitA Tech Live. I think you need to open your PowerPoint. What we're seeing is the CitA Tech Live screen. Just share again.
Let me try one more time.
Yeah, no problem at all.
Are you seeing that now?
Yes, we're seeing it now. Good to go.
Sorry about that. Anyway, as I was saying, wasted time and resources. The design bid build process is clumsy at best. And then, of course, our industry, unlike most, have not been able to take advantage of the economies of process without moving some of that work offsite. So this is one of my favorite diagrams, and sort of the way I like to think about the paradigm shift of design, manufacture, construct in lieu of the conventional process. And this is what we are shifting as an industry today. And this slide elucidates several things. One of them is that in our standard construction process, we don't establish the final cost until well into or almost at the finish of the building, as opposed to when you add manufacturing to it, you can actually establish the final cost of the building or almost complete final cost of the building once your design is done and ready for manufacture. This obviously can net what developers are interested in, which is up to a 50% time savings and a 25% cost savings. And these are some of the other value propositions: lower building cost, faster production and delivery of developments, obviously safer work conditions. You've seen that from some of our other presenters today. Almost complete time and cost certainty. It's working in an environment like New York, the neighborhood disruption is often a huge problem. Our solution doesn't require any scaffolding, doesn't even require a hoist. The building is delivered fully waterproofed and enclosed and almost completely finished. And then from a sustainability perspective and carbon footprint, we have 67% less waste at a minimum, and we're talking at less than 5% total waste. So this is really where we started, and now I'm going to talk to you about the idea of implementing a systemized approach to creating the built environment. So we have created a organized and parametric process for creating the built environment. The interesting thing about multifamily housing, especially mid to high-rise multifamily housing, is that the parameters that are created by code and regulations drives very limited choices to what you can actually do to a building. And at the same time, for some reason, our AEC community has still managed to treat every multifamily building like a multifamily building has never been built before. And hopefully some of you are smiling. It's absurd. Basically, multifamily buildings are very similar. And you want to build a building that is high quality, that meets the needs of your customers, that is as small as you can build it and still be marketable, because you increase your return on investment, et cetera, so on and so forth. And so understanding that, and adding the volumetric parameter to it, the process is pretty simple. And we at FullStack have been pushing that and have made tremendous headway along those lines. So, so if we think about the assembly, we see we have a set of unit types and a set of unit combinations that allow us to build a multifamily building. This is, as Ravi talked earlier, this is the process of productizing multifamily housing with enough flexibility to meet the needs of the developer and the end users, but also enough process to create economies of process. So our world, unlike the construction world, which is divided by trades, our world is divided by assemblies and sub-assemblies. The assemblies are the units that we were just talking about, and the sub-assemblies are the pieces that go into it. Now, those pieces can be MEP systems, they can be fully integrated kitchens, they can be bathroom pods, and in our case, we have facades that we install in the factory, and all of the subcomponents of that. We organize our manufacturing process in that fashion and not in a trade fashion. All the workers at FullStack Modular are workers at the company directly. We do not have any subcontractors. So all of the work is done in an organized, manufactured-focused fashion at our factory, our first factory in Brooklyn. So we hear every day about technology and construction technology, and one of the things that is often that is often overlooked is that our process on the construction site, we all know, is incredibly inefficient. And utilizing advanced construction technology on the construction site is quite complicated. On the other hand, in a factory, it's pretty easy. So at Full Stack, we have focused first on what we think is the primary risk of building offsite multifamily, or any buildings for that matter, and that's dimensional accuracy. If you do not build the building accurately per the model, you're going to have problems either in the factory or when it arrives on site. And so we have developed systems both in the factory and on site to maintain tolerances of a 1/32 of an inch or less, both in the manufacturing process in the factory and also checking the accuracy of the assembly on site before we send more mods for manufacture. We use a fully integrated system from purchasing to manufacturing to implementation, and all of the model and production drawings, which are specific instructions on how to build the building, and integrate them. And we are continuously incubating new technologies with companies all over the world in order to improve that process. And some of them are focused on the site metrology, some of them are on the organization of our work, some of them are on an analysis of the building that we're creating, and the sustainability of the envelope that exists within it. And then some of it is just energy focused. And so we are constantly doing that. So as a way of talking about what it is we do, I thought I would show you, we'd create a building on using our system online right now. So Alan, I'm presuming you can see my screen now?
Yes, good to go.
And it says building dimensions on the left-hand corner there?
Yes.
Okay, great. Thanks. I appreciate it. I just never know if I'm
No, that's okay. You're doing great.
Okay. So let's take a standard multifamily building in New York of the larger size and say it's 100 feet long, and that its standard residential depth here is somewhere between 65 and 70 feet, and that we have a building height that we like to do mid to high rise. So let's say we're going to go 150 feet tall. So now we have a bunch of questions to answer. What market are we building for? These units, as you might guess, are actually pretty large and probably are not very marketable from a value cost per square foot. Whereas these units would be incredibly micro units, co-living, et cetera, so on and so forth, and probably not the ideal thing for this area. So I'd say we'll go with 12.5 foot wide. You're going to end up with 600 foot units-ish on the one bedroom side. And then this will give us all of the parametric options for the unit combinations for a building. So we're trying to veer away from large units that have low yields, but let's just say this is in an area where there's a lot of families, so we're gonna pick one that has more 2 bedrooms, and that's it. And now we have the question of how high we want our ceilings to be, and obviously you have to look at the regulations as it relates to where the location is, but if you use a 10-foot floor to floor, you end up with an 8'7" ceiling, and that's generally you want to max out your floors. You want to have 15 floors of building rather than 13, but you do have those choices if you say we're building condos, et cetera, so on and so forth. So that's the unit design that we've just done this quickly. Now we're going to look at the massing. So this is our building on a site. And this is a facade that we've done as an example of what a facade on the modern side could look like. But we think that this is in a more industrial location, and the traditional, sort of a metal-clad windowed system is not very good. So maybe we want to do it in a more traditional brick solution. Then we're going to see the units, studio layout, 1-bedroom layout, 2-bedroom layout, and then we can, and this isn't going to come out really well on the screen, but if you play with it on our website, you'll see it. You can do a complete walkthrough, look at the units and see how they're operating. But not only can you do that, you can actually say, okay, what if I made my ceilings higher? What would it look like? What if I decrease the size of the unit width, et cetera, so on and so forth. So this gives us and a developer very good information very quickly as to what it looked like. And then this metadata that's created within this system is giving us an opportunity not only to know what the building might look like and how it would work for the developer, but it's also giving us the data so that we're able to price out what the modular portion of this project is in very short order. Now I'm going to go back to my presentation if I can.
It's good to go.
Thank you so much, Alan. I appreciate the coaching. So then our process really has 3 major components: the design, the manufacture, and the construct. And the design side of it is data-driven. As I just showed you, we do it a modular analysis, which doesn't take very long, atypical of a architect doing a schematic design and a fantastic GC or construction manager doing a rough estimate and then realizing it's too expensive and going back, as you saw in the diagram that we did earlier. Then once that's agreed to, we start our design for manufacture process, which means we are taking the model that we have from a schematic, an engineered schematic solution, and turning it into a specific instructions on how to build the mods that we have designed. And then that gets integrated into our digital workflow, which is, as I explained earlier, or anybody who sort of had experience with the ERP system, flow from purchasing of product to delivery of and installation of the units as they go into the building. Manufacture, our building component is a metal chassis, which is actually a Virendeel truss system that has the capacity to go to 45 stories using its own structural system. We use no concrete in our structure. And everything from the point that we sit on, whether that be a plinth or on top of a parking lot or on top of a commercial space, all the way up to the roof, is entirely modular. We assemble our units in assemblies and sub-assemblies, as I explained earlier. Everything is integrated. It is a full structural, mechanical, electrical, and plumbing distributed system with all of the connection pieces sent with the mods to the site. So once you're done with your foundation, everything that's needed in the building until you get to the roof is sent with the manufactured mods from our factory to its ultimate location by train, truck, or boat. We happen to be actually adjacent to a dry dock, so we do ship by water sometimes. And then in the construction side, we transport the mods. They're wrapped, they're waterproofed, they are stacked. And as I mentioned earlier, it's actually unlike a wood product. these units are actually very rigid, and they have extremely tight, as I said, 1/32 of an inch tolerance. And the system has adjustments built into it that allows you to adjust for any, steel problems, settling problems, et cetera, so on and so forth. And our mods are picked up, as you can see right here in this picture, they're picked up right from stay-in-place lifting lugs that are built into the mods and stay there as the building goes up. And then the temporary EPDM roofing, which is used in the event that you have inclement weather while you're stacking, also stays in place. It's type A, et cetera, so on and so forth. And then the mate line work, which is in our system, just connections. So all of the mechanical, electrical, and plumbing connections, and then the structural bolting. I guess I should mention, there is no welding done on site in our buildings on the modular portion. Everything is bolted together like an erector set or a set of Legos. And then the units are then finished. We try to keep those connections focused on the hallway so that we can completely finish the units before they leave the factory, including painting, flooring, electrical fixtures, accessories, furniture if you want. We really can put anything into the building. We are looking forward to the day when we can actually move a family in before the building's built, so pre-occupied buildings, but we think we're a little ways from that. But we actually could physically disassemble this building without too much complication once you figured out what you wanted to do with the mechanical systems as they got disassembled. The advantage of this process is that iteratively, we create a library of products that we can organize, reorganize, and reassemble in different locations. And in addition to that, it allows us to analyze the units, the data, and also the operations of the building by virtue of our ability to integrate any piece of sustainability or any product or monitoring product as we're building the buildings at little to no cost. Additionally, it allows us also to build incredibly sustainably. We are working on several passive housing specified buildings right now. It's pretty easy to integrate. Obviously, you end up with thicker walls, and you sometimes have cost of materials that are beyond standard conventional solutions. But from a labor perspective, we're able to keep that equal. And then our process is pretty simple. Modular analysis and initial estimate, modular blueprint agreement, which we use is an engineered schematic design, which takes somewhere between 8 and 12 weeks. And then that gives rise to a modular construction agreement. We are a fully integrated solution, so come to us with a product you want or a building you want, and at the end of the day, we're going to turn over the keys, fully bonded, licensed, guaranteed maximum price. And we are, as I said, located in on the East Coast of the United States, soon to be expanding. So I thank you for your time, and obviously would welcome any questions that anybody might have.
Thank you, Roger. Fascinating presentation. Of course, you can build, you have no restrictions in building high, like we have in our country, maybe other countries. So fantastic feat in action. Again, my chairmanship is such that I know we were slightly over time. It's to do with the chairperson. Sorry about that. But listen, that was absolutely fantastic. We might just take one or two quick comments and then we'll come on to our final presentation. I've no problem running in beyond a little bit beyond 3:30 if people want to stay with us. I know there's a few questions there we'd like to tease out with people. But I know there was one comment there from Martin. Martin, you had a question about the golden joints.
Yes, Alan. It was just when you're starting to pressure test these things, I know Roger there said he only uses bolted connections, so there's no field wells. But as you rise up through the different levels and floors, the pressure has to increase to reach up to the high level buildings. So how do you overcome that, or how does the joints meet the standards or the requirements for that, you know?
I mean, we have, it's a great question. I mean, we test in the factory for all the components to 90 pounds. And then the systems, as they go up the building, I mean, there are some relief joints installed, but we are using at this point for even our 35-story buildings, you know, press fit Victolic or no hub connections, and they're working quite well.
Okay, I know you can stop sharing your screen there now, Roger, if you don't mind. You did a great job. I'm sure there'll be other questions maybe at the end. We're going to come.
My presentation today is around really kind of looking at the enhancement of digital data. Diatec are a technical services company, and kind of our role is kind of helping people use their data in more effective ways. So one of the ones we've been kind of heavily involved in over the last couple of months is really using alternative technologies to get the most out of your data, kind of looking at the whole area around modularizing your data for different uses other than just on the provision of specific needs of project delivery. So let's just move forward. So what I'm going to be talking about very briefly is introducing the technology Unity, talking about a few examples of how we're working with our clients to leverage that data, and how we're looking to provide that information to a wider audience than just maybe specific project delivery teams. And then invitation to find out more at a time of a webinar we're hosting in the next couple of weeks. So Unity essentially allows us to look at ways of providing an environment and a platform to share data in a non-static way. But not only that, but it allows us to create additional outputs for how we share and absorb that information. So there's two components to it really from a provision standpoint. We have Reflect, which is a plugin for a good portion of the design tools that are commonly used. That Reflect plugin allows us to connect to the Reflect server, which can be hosted locally or via the cloud. And then we create a bespoke viewers or use the standard viewers, which allows us to push the BIM information to a multitude of different devices. So we can take the information live and create live collaboration and communication environments. So to kind of put into context, we can very quickly ship out our information from our design environment, host it in a live engine, and then allow us then to present that back to a multitude of different devices. Then we can start using that for different contexts in terms of collaboration and communication. Now, the key element in the Reflect environment is it's live. So as a designer is moving through the design tools, we can then reflect that information back into these native formats, whether it be on a desktop or on an iPad. And because it's based on gaming technology, it optimizes the experience to make it very easy to scale this up for different devices. So you can then, provide different solutions and different access to the BIM data. So users on mobile devices and iPads, for example, can project the model into their environment. They can walk around it. They can look at the information contained in the digital information, and they can view it in any way, shape, or form that they want. And that allows a little bit more freedom in terms of how we can then start to look at how we use our information in more ways. Now, we can take that a step further by then incorporating the development platform of Unity Pro. Now, Unity Pro allows us then to take the capabilities of Reflect and extend it to do more functional capabilities that are specific to a particular challenge or pinch point that we have. So essentially what we're talking about is modularizing the data to different types of outputs that are specific in terms of requirement and need. So what really happens with the Unity Pro environment is we start to incorporate other aspects of the informational capabilities that we have available to us. So in terms of things like metadata, we can then start to scale out the device and delivery, and ultimately to start building a custom experience for how that information is absorbed and used. So to give an example of how that's been approached, we have an architect in the US who's taken the Unity environment and then started applying that to a multi-aspect approach of how the information is absorbed. So on the left, we have an iPad approach where they're essentially pushing information on top of a physical model representation of a building they're working on. And on the right, we have the iPhone representation of it, which is essentially the same experience. So the key thing in this is it allows us to take the data, build it into a module where we can actually then decide how we then push that out to the wider audience in terms of them, how they absorb the information, how they use it, and then ultimately how they then start conveying information back. Another example we're working on is looking at other aspects of, say, the whole process of delivery of construction. So, for example, we can start to look at how we start to build out construction sequencing and how we can convey that to a wider audience who may not necessarily have access to the design tools or coordination tools. So using the same technology, we can then start to function in other aspects of construction and construction management, but all within the same native ecosystem. So we're really kind of leveraging information we're generating as part of our processes here, and then creating an environment and an interactive experience so people can actually start to absorb and see the information in a format that makes sense to them. But again, we're not recreating the wheel on this. We're really just reusing the same data that we're using as a part of our functional processes. Here's another example where we're looking at a particular aspect around the area of, say, clash coordination. So through our normal clash processes, we might be generating information that are specific to individuals in the organization, but other people may want to absorb that and see what's going on. So using Unity Pro and Unity Reflect, we can then start to take the pre-built Unity Reflect experience and enhance it by creating a custom viewer, which will allow us to take the Excel information coming from our clashes and use that to create a custom viewer, which will allow us to show those clash points within the model, for example. So in each of the examples, what we're trying to do is we're looking at the case study requirements of what functional tools do we need to help the communication and collaboration process and make sure that everybody is aware and is readily has access to the information and to the data, but in a form that is easily absorbed and easily used. So if I go forward here, another example, and again, this is all using the same BIM model information, is we've created points of interest within our design, and now we're actually adding in some functional intelligence where we use the tools that are built into Unity to create things for, say, emergency scenario modeling. So we put the people in, these all come with the Unity platform. We give them some intelligence in terms of, you know, interactivity about how they will move throughout the building. And then they will then naturally move to the nearest points of interest. In this case, these will be kind of emergency points where they'd actually come back in and stand still in the middle of the site, for example. So what we've found over the last couple of months is that people are starting to understand more about the whole collaborative and communication aspects of project delivery, and they're looking for more functional ways that they can actually start to interact more readily, more frequently. The beauty of the Unity environment is that the actual process of actually collaborating means that the viewing tools that I've shown on the screen here are free and readily available. The cost of investment and time is really in the creation of the actual scenarios and the experience themselves. So we've been working with quite a few clients over the last few months about really kind of understanding their use case models and for how they want to develop out new solutions that differentiate them from their competitors and from other people. And secondly, how they can start to use their digital data better to convey intent, to convey context and that nature as well. So again, I'm just conscious of time, so I won't kind of preamble too much. If interactive and immersive capabilities are something that you're interested in and you want to get more involved in, we're having a webinar that one of our clients is actually presenting on October the 14th. If you want to reach out to, my email address is there. And if you want to kind of get involved with that, feel free to do so. So Alan, I will hand it back to you.
up if I may, because I'm conscious of the time. Thank you, Raghi, Forrest, Anna, and Roger, and David for really some insightful presentations. Raghi spoke about moving from the field to the factory. The new norm of industrialization is the way to go. I would agree. Forrest, he had to leave us a little bit early, but I mean, his focus on continuous improvement, you know, industrialized construction, mass customization, automated design, that's the way these modular companies are going. And I think did a very good talk on a sustainably focused, industrialized, I suppose, culture in her business. Obviously a long history of modularization in Sweden, unlike our own country. And indeed, Roger, I mean, it was great to see that interface, the design interface, you know, that you showed us there. That was really, really good. And I can see the challenges you have with the different codification in the different states as well. And so again, you reinforce that whole data-driven design process. So that brings us really to the end of day 5. Unless there's any questions, I'll wait a few seconds. If not, I'll summarize the week. Okay, so it's been a very interesting week. 5 days, 15 hours of content, which we'll be pushing out through our social media channels over the next while. I'd like to thank all our audience for being with us over the last 5 days. I might just summarize where we were with the speakers. You know, on day 1, Eva Jeniku spoke about her 7 sustainable business opportunities. Hadel Sadoun did a great job on talking about how they're using digital twins in Coventry University. Simon Evans did a wonderful masterclass on digital twins. Bruce Mace talked about the need to, I suppose, not to dance with the twin and to set your threshold low. Mike Stenson and Kingspan did a great talk about how to, you know, by building a living lab, they can learn how to improve their products. Phil Bernstein did a great talk on the potential of machine learning. Alice Long spoke at length about new technologies and new startups and where the opportunities were. Daniel was a little frustrated on day 2 about the archaic work practices we have in construction and the need really to change the work and our procurement methods. Ronan did a great talk on data management on day 3. Niall spoke about the new changing, I suppose, environment and you know, in fostering an entrepreneurial culture in business. Emma Hooper spoke at length about the importance of data management. I learned lots from her. Vicky Reynolds spoke about culture shock. Alice Jennison spoke about diversity inclusion. We could also see that today in Alice's talk. Culture Nut talked about the pipeline of new technology companies coming into play. You know, Roger today did a great talk on modularity in action. Forrest, I think, did a great talk as well and mass customization and, you know, how they're constantly improving their business. Raghi, once again, a great talk on the acceleration of modularization. And Anna, again, topping off, talking about how you've brought the whole circularity of the business together. So in all, it's been a great 5 days.